Hello, I'm Jim from the United States. Hola, buenos días. Soy Jim, Estados Unidos. Hola, buen día. Soy Jim, Estados Unidos. The controller on the handlebar, that's a different thing. It has two adjustments. One is on the front here that adjusts the position of the lever in or out. Some people who have smaller hands, they want to move the lever in, or for a youth rider. That's all right, except that when you do that, you have to remember that there's an adjustment that sets the lever to the piston, which moves the fluid, and that's the one on the lever itself with the small 10mm nut. I'll move in here and see if we can show that a little better. Okay, I'm going to follow this with a still shot showing that there is a circlip, a small clip inside the bore of this master cylinder, and that piston, that hydraulic piston, has a ridge on it, and that piston must always come out and touch that circlip. That ridge stops against that circlip, and that's the outermost position of the piston itself. It has to come out that far. So if you set the lever in, you're pushing the piston in part way. And why does it have to come out that far? Two reasons. One is so that it can open the feeder hole in the reservoir here so more fluid can enter the system. That feeder hole opens to fill the system only when the piston is fully out to its outermost position against the circlip. The other reason is if you are using only part of your piston travel, your clutch won't completely open. The piston needs to go through one complete stroke to move the correct amount of fluid through the hose to the slave to push the pins, the push rods, which open the clutch. If you don't have a full stroke of the piston, your clutch will definitely drag. Here we have an example of a properly adjusted clutch. The lever comes all the way to the grip. In this position here, it works well with one finger. So you can see that the clutch master cylinder is set inboard. This motorcycle is ridden by an expert former national champion. This is the way he likes it set up. So we have a little free play, and that is because there's a push pin between the lever and the piston in the master cylinder. This little push pin has this rubber dust boot attached to it, and behind that dust boot is a small spring, and that keeps tension on these parts so that the push pin doesn't fall out. So what you see in the free play is actually just the spring and push pin. The piston is coming all the way out to the stop, which is the circlip that I explained elsewhere in this video. Now I will demonstrate what happens when you have improper adjustment. So I'm going to first demonstrate by turning in this adjustment screw too far. Now what we have is we have a lever that stops before it hits the grip. You can see here that with it pulled fully in, I can pass this wrench behind there. Okay, what does that do? Well, it prevents the piston in the master cylinder from coming back to that circlip stop, therefore preventing fluid in the reservoir from replenishing the hydraulic system. So when you take this screw and you take it out too far, you have excessive free play, and you don't have a complete movement of the piston in the bore. It's not going all the way to the end of the bore, so therefore not moving its entire amount of fluid that it's capable of moving. So ideally you have this set up so the preload on the push pin between the piston and the lever allows you just a little bit of free play, and then you get the full stroke of the piston, which moves the maximum amount of fluid through the system, and as explained previously, you have the lever coming to the grip. And as I explained previously as well, if the lever itself is bent, especially if it's bent back, it will contact the lever prematurely, and for that reason you won't be moving the piston through its entire stroke. A common misconception is to take away clutch drag pushing in this pin. Actually, that adds clutch drag because you're pushing in that piston into the bore, preloading it, and therefore you're moving less fluid in the stroke of the lever than you had before. So less fluid moving down through the hose into the slave piston means less distance pushing on the clutch itself to open it. So continuing to tighten this screw by pushing it in actually makes your clutch drag more. So if you're unable to eliminate clutch drag by adjusting this, then you have another problem down below in the slave or in the clutch plates area themselves, which I explained in other videos. I want to also mention that if you see a green cap here, this means it's a mineral oil system. I don't know if you can tell in this video, but this is a dark green color, the cap here. And that's industry standard. It signifies that this system on this motorcycle uses mineral oil, not brake fluid. So if you're going to adjust this screw out here, the one that moves the lever in and out on the handlebar, keep in mind that you should also compensate that adjustment by adjusting this one as I explained. Those of you with smaller hands may wish to just move the master cylinder out a little farther so that you can work the lever in this area. A larger hand person can do it out here. I want to mention as well that because you'll often see trial riders running the controls more inboard like this. The reason is when the bike tips over, when they drop the bike, the lever is more inboard and less likely to break the lever or bend it in a crash. And they get to use the lever out here on the end for more leverage, as well as being able to pass the lever under the finger like that and get it up against the grip. So this is why you'll often see the trial controls mounted farther inboard. The design of the clutch and front brake master cylinders is virtually the same, only they are mirror images of themselves. But keep in mind, the clutch master cylinder, it travels the piston entirely through its stroke during the movement. And if you ride the clutch a lot, which is normal in today's trial techniques, you may find that you'll have to rebuild this occasionally, and that's because this piston is going through perhaps hundreds of thousands of revolutions of the stroke. Sometimes it's necessary to replace the whole master cylinder when the motorcycle is older because the bore inside gets worn, and the bore gets worn into an egg shape. It's no longer round, and that's because by design this lever arcs into the piston, so therefore there is some side load. The reason that the front brake master cylinders last longer internally is because the piston doesn't move very far in the bore just to tighten up the brake caliper. So that piston stroke in the front brake master cylinder is much less of a distance. And keep in mind as well that you cannot use mineral oil in a brake system. It's only for a clutch. Brakes must use brake fluid .3, .4, .5, depending on what it is called for in its application. On our website, on our tech page, are some bulletins, and attached to this video, you will see in the video narrative, you will see links directly to these different bulletins that have pictures and written descriptions and measurements and so forth. Thank you very much for viewing my videos.